Hello, this is Sorjura. In episodes 4 and 5, we learned how to select a sound or wave asset from the outside, like a blueprint or data table, and push it into MetaSound. But today, instead of looking outside, we will learn how to select and change sound entirely inside MetaSound. We already learned the easy way to change sounds with name tags outside, so why are we going back inside the MetaSound? Let's take a fireable skill sound as an example. What if it makes the exact same sound every time the player throws the fireball? It will get boring quickly and sound very awkward. So we usually create 4 to 5 slightly different fireball variations. But should we write down all 4 or 5 sounds individually in the external data table? No, that is far too inefficient. From the data table, we just toss a single name tag called fireball to MetaSound, then inside MetaSound, it automatically picks and plays one of the 4 or 5 fireball sounds it holds inside. In short, the outside gives a broad command like play fireball sound, and the inside mixes in detailed randomness to make the game sound rich. And honestly, unless it is a small project, as the development team grows, the division of labor becomes strict. Touching actors and blueprints, which are the developer's domain, actually makes collaboration more cumbersome. It is much more efficient to let developers simply trigger play in blueprints while the technical sound designer handle everything inside MetaSound. So today, using the sound of a flying fireball, the fire whoosh as our theme, we'll dig into the core nodes frequently used inside MetaSound when creating one-shot sound in the field. First, right-click in the contents browser and create a new MetaSound source from the audio menu. Let's name it MSS, SFX, Skill, One Shot, Mono, Fireball, Whoosh. Double-click to open the window. When you first create a MetaSound, the output format will be mono by default. You see our mono in the center graph, right? We are making a 3D trajectory sound cutting through the air, so the mono format, where position is crucial, is perfect. You can leave it as is. Now, let's not forget the LP player to play the sound. Right-click in the empty space and bring out the wave player mono node. From the on player node on the left, drag the white execution line with your mouse and plug it into play pin of the wave player. Plug unfinished into the output unfinished as well, and plug out mono into the output out mono. This completes a very basic command. When MetaSound starts, play the wave asset in the wave player and output as mono. And when the wave asset finishes playing, end the MetaSound. Now we will make the 4 fireball launch sound play randomly. Here, pull the wave asset pin of the wave player and create a random wave asset node. Look at the left pin of the random node. You will see an in array pin. It is asking which bundle of sound will I choose from. Drag this in array pin out and click promote to graph variable. This creates an array variable that can hold sound. Let's name the variable fireball whoosh. Drag and drop the 4 fire whoosh sounds you prepared in the details panel. And connect the input pins in order, otherwise the sound will not play. By the way, the fire whoosh sound we just put in is stereo, but it'll play in mono, so it might sound a bit different from what you heard. Usually, we convert stereo to mono before importing it into Unreal, but I will just skip that today because it is tedious. The important thing is how we build it, not the sound itself. Anyway, to continue the explanation, this random node has a fatal flaw. It is a pure dice roll, so if you are unlucky, the exact same sound can play consecutively. If you shoot fireballs in a row and get the same sound, the randomness is pointless, right? That is why professionals use this node. Delete the existing random node and bring out the Shuffle Wave Asset node from the search bar. Shuffle is exactly like the playlist shuffle in your music app. Until all 4 fire sounds have played once, it'll absolutely never output a precisely played sound. For your information, many people do not know this. You have to create a trigger pin in the input and test it using the simulate button of the trigger. The play button at the top of the MetaSound editor is like rebooting the entire system every time you press it. So the playback's history that the shuffle node remembered gets reset. I'm giving you this tip because I have a dark past of pressing it forever and wondering why the shuffle not working. Anyway, let's breathe some life into this fire. Pull a pin from the wave player's out mono, create a bytecode filter node, and plug the filter's out pin into the final output mono. I'll set up the filter type to high-pass filter. Low frequency sounds handle the weight and energy, but excessive low frequencies in these sources are hard to hear and only eat up the sound pressure. Next, I will bring out the LFO node. LFO stands for low frequency oscillator. It creates an inaudible waveform. This waveform is used as a controller for other nodes. We are going to make two LFOs. We plug the first LFO into the pitch pin of the wave player. To clearly hear the change, I'll set the values a bit wide. We plug the second LFO into the cutoff frequency pin of the bytecode filter. A filter needs to sweep across a fairly wide frequency band, opening and closing to be dynamic, so I will also set the min and max values for this a bit wide. Note that the frequency of the LFO literally means the cycle. It is about how fast it undulates. And since I prefer a slower pace, I will set it around here. Shall we play now? And simulate the trigger we made earlier. The sound got more interesting, right? This is the beauty of sound design. Now that we made the sound dynamic, let's polish it to make it solid. No matter how precisely we edited the 4-fire sound, their volumes are bound to be different. When you manage a lot of sound effects later, you will definitely run into situations where some are too loud and hurt your ears, and some are too quiet to hear. The node we use for this is the compressor. Let's drag a wire out from the out pin of the bytecode filter, search for compressor, and connect it. The most common misconception among beginners is thinking the compressor is a device that fills the density of the sound. That is absolutely not true. The real purpose of a compressor is to press down excessively loud sound and put up quiet sound, reducing the volume gap so the player is not uncomfortable. Now, the compressor has 4 core pins. Threshold: at what decibel level should I reduce the sound? It sets the reference point. Ratio: how much should I reduce the sound that crosses the threshold? It is the compression ratio. Attack: how fast should I reduce it? It is the reaction speed. Release: when I should restore the reduced sound. It is the release speed. I'll set the values similar to the CLA to a opto compressor I enjoy using. A proper ratio of 4:5 and a slight slow attack to preserve the initial hit, while giving a short release time of 15 milliseconds to create a bit of pumping. Though in reality, it is a dual time release, so it is slightly different. I'll set the threshold around -18. Once you have adjusted these values to stably polish the 4 uneven sounds, put a wire from the audio pin of the compressor and connect the limiter node. In a professional environment, the limiter acts as a ceiling for the sound. In actual game development, we do not mix every sound effect to be heard perfectly. If the BGM, voices, ambient sounds, and skill sounds are all at maximum volume, the player will not be able to hear anything properly. So in the field, we set limits for each category, saying this specific sound effect must never exceed this decibel. The limiter is exactly this absolute ceiling. No matter how loud the sound gets, it sharply cuts off the tail end so it never exceeds the limit range I set. protecting the mixing balance of the entire game. Shall we take a look after connecting our mono? The threshold dB is the exact ceiling, and based on this ceiling value, the sound will absolutely never go higher. By the way, if you are asking what if this sound is too quiet, how do I make it louder? Just create a mixer between the compressor and the limiter. And drag this gain 0 pin to promote to grab input to create a float input value, then you will get a knob you can adjust. Set the range as much as you want in the details panel on the left and turn it. Since the limiter is connected after the mixer anyway, the sound will not go above the threshold you set. If you wonder, how do I know how many decibels it went up? You can just connect the decibel to linear gain node that I mentioned in part 1 in between. Then it takes the gain of that knob in the decibels we know, converts it into the linear gain the computer understands, and delivers it to the mixer. Make sure to save the fireball whoosh sound we made today. Next time, I think this is actually the core of MetaSound. We'll learn about the trigger system that receives collision signals from an actor, activates the MetaSound trigger, and blasts an explosion sound. That is all for this video. See you in the next time.